So you can see here when I'm trying to put knn.fit and passing x as a input and y as a output, y as a output. So what is the issue in prediction? Okay, so now we are walking in the flower garden of Sitosha, Vertical and Virginica, found three flowers, measured length with asking machine to find the labels. So here in prediction level, note in the use of all known 150 sample rows used in training the model, can you comment the machine answer are correct or wrong? So we cannot comment without splitting the data test, train and test data. We cannot comment like, hey, machine is giving. So this 0, 1, 2, we cannot comment that this machine is giving a correct, correct or wrong answer. Even though what was the issue again, measuring model performance, we can in classification accuracy is commonly used with accuracy is equals to fraction of correct prediction. Accuracy means fraction of correct prediction. But as we are not in position to justify the machine answer right or wrong, so we cannot calculate the performance or accuracy. So this is the issue we have already discussed in last session. If you are not splitting the data into the train and test data, so this is the issue. So what is the meaning of machine learning is I have already described like you have to train the computer, train the machine, then on the basis of that you have to give some test. Okay, you have to appear for test. If in test accuracy is very high and accuracy, that means performance is very high, so you can say that your model is very accurate model. So ultimately what is the goal? Ultimately the goal is to we have to create some model means like a model is just like a, if you say like in programming, model is just like a method or function or a way of work. Same as it is, we will create our own model. Okay, first we'll see first we will see defined model, then on the basis of that we will create our own model. Even though in even though with deep learning is also a part of machine learning. Deep learning is also a part of machine learning, but where we will work with the neural networks. Neural networks means like a where we'll work with the large data sets. Here data set is limited in compared to deep learning, data set is small. But if your data volume is large, in terms of billion, so that times you have to go with the deep learning concept. So deep learning is also a part of machine learning. Okay, but the concept wise little bit every little bit different. Okay, some topic is different, so that's why we decide to divide that concept separately. So coming to that today's session, I have covered this session in previous class. Coming to that this session, now I want to define the data into the train and test data. So what is the meaning of train and test data? Train means, as you know that, let's suppose I described you 5 programming questions. So this is this the meaning of this this is a training you. I'm giving a training. After that I want to know that hey, our training is successful or not, I want to test you. So this is called test. Same as it is, first I will train the data. Okay, train the data, and then after test the data. So here for training and testing, what modules? First of all, for creating any models or testing, what you have to do, the step one is you have to import required modules. First step, you have to import required module. Then the second step is you have to load and understand the data. What is our data? You have to load. Then third step is you have to split the data for training and testing. So first step is what modules is required for creating your model. That modules you should import. Then you have to load the data. Then whatever data you loaded, you have to split the data into the two part, training and testing. So this is the three step. Then after, once you will have received the data and splitted the data into the two parts, then after you have to fit the model. Fit the model means fit the model means when we have a function here, fit model, it will be automatically fit the model. That means what algorithm is required, what leaf size is required, what neighbors is required, which Minkowski metric you want to use. It will be automatically fit. You no need to worry initially for this. Then after, once our model is fitted, that means fitted, then I want to predict levels of test data. I want to know whatever data we have tested, I want to predict. Then after the prediction, I will match with that accuracy. What is the accuracy in between test data? That means, let's suppose I trained you. Okay, I trained you. And I have given 5 tests to you. Then I want to know that what is the output after the testing. What is the output? What is your predictions? What machine gives some prediction? On the basis of that, I will find the results. That means accuracy. Let's suppose I give you 100 questions. In 100 questions, you solved the 90 questions accurately. That means I say your accuracy is 90%. Your accuracy is 90%. So same as it is, we'll see then accuracy. Then after will come for hyperparameter tuning with grid search CP. So let's do practice till accuracy. Then we'll come into that grid search. So before going to the grid search, I will again come back on chapter 2 here, and then I will describe internally how KNN classifier use this not here, not chapter 3, chapter 2. So I will describe here how KNN algorithms internally work Bruti, KD tree, ball tree, and which one is the better. Okay, so by default KNN algorithms will not accept below values. Which one is random tree? So I will describe these algorithms, and then I will describe what is non-programmatic method and programmatic method. Okay, but today we'll do practice till accuracy, how to find accuracy here. Got it? So this is the goal for today's session. So let's start practicing along with me. Okay, and then first of all, tell me what is the step first. What is the step first here? What is the step first? Tell me step first. What is the step first is? Step first is, tell me guys. Yeah, import. Yeah, so step first is we have to import required modules. You have to import required modules. This is the step first. Step first is we have to import required module. So what is all required module is first required module is, as we know that we are learning machine learning. So for machine learning, the most important package is called sklearn. So from sklearn, I have to import from sklearn I have to import first what is required data set is required. So I can, yeah, you are right. So I, why it's okay, it is taking some time. So I can import data sets. Got it. Then after I have to import from sklearn dot model selection. I have to import from sklearn dot model selection. I have to import train. Oh, 1 second. It is taking time for searching internally. Okay, so I have to import train underscore test underscore split. That means this package internally divides, gives some function to import split data into the train and test data. Then after, as we know that NumPy is then after I have to import from directly I can import here, import numpy numpy as a np. Then after, what is required, tell me, from sklearn what is required, from sklearn dot what we are learning here, knn means k nearest neighbors. So I have to import sklearn dot neighbors. Then from sklearn dot neighbors, then I have to import here, k neighbors classifier. What is k neighbor classifier? Okay. Then after I have to import here from sklearn I have to import here matrix. Okay. Then I have to import what is accuracy score. I have to import here accuracy score. So this is the required package. Is data sets, model selections, okay, then NumPy, then Knn classifier, then accuracy score. Okay, then accuracy score. Right. Then after, what is the step two? What is the step two? Then after, what is the step two? Step two is I have to load and understand the data. Load cap load and understand the data. Load and understand the data. This is okay. So step two, load and understand the data. Step two, load and understand the data. So which data we are learning here right now? So required is iris data. You are right, Ashif. Iris data. Data set dot load data set dot load iris. Data set dot load iris. Let me know why. I have Ashif, Pratik, can you drop the message in group so that they can, because email is required. I want to know everyone availability. Can you drop the? Could you drop 1 second, please? Venkat, could you drop? Yeah, Pratik, could you drop once again? Pratik? No, I'm not asking your email ID. I'm saying that, Yeah, Pratik, can you drop a message in group so that all the students can join? Okay, do that. I don't have access of my mobile phone right now. Do that, please. Okay, so data set dot load underscore iris load and understand data. So what is the meaning of load and understand data? Data set dot load underscore iris. So this is the way we can load the data. We can load the data, and I want to store the data into one variable. It's called iris. That that is fine. Okay. Then after from Iris, I know that for machine learning, okay, so we have to require some input data, okay, and on the basis of that input data, output, if output is given, that means level is defined, that you can say that this is the supervised learning. And if your label is fixed, that means definite, so you can say here supervised classification learning. So as you know that what else what so as we know that we are learning KNN algorithms. Which algorithms we are learning here? KNN classifiers. Classifier means like our label should be definite. So same as it is, we have to pass here. I want to load the data. Let's suppose I want to know that what is the iris in iris. So we can print here, print iris, iris dot keys. We can print iris dot keys. So we can see here in this iris dot keys we have a data, we have a target, we have a target name, we have a description, we have a features name and file name. So this description, data, target I have already described in previous session. So I don't think so. I have to describe right now. So in data, you can see here, in data, we have see here like four attributes in data. One is, one attribute is, one attribute is, what is the iris? Iris is a flower. Okay, iris is a flower. In iris flowers, we have a sepal length, sepal width, petal length, petal width. I have already described what is the sepal, what is the petal. So same here, we are taking the input as a sepal length, sepal width, petal length, petal width. Then after I want to find out target. So what is the target is here? We have a three target. Target is 0, 1, 2. So what is means 0 means Shitosa, 1 means Vargicolor and 2 means Virginica. So once you go with the data, you can find easily what is the data. Once you go with target, you can find easily what is the target. Once you go with the target name, you can find easily what is the target name, what is the description, what is the features name. So in features name, you can see here sepal width, sepal length, petal length, petal width, and then file name. So you can go through with the data. If you are not if you missed in previous session, so you can try with your own. Okay, so as of now I want to know what is the target. So if you want to know what is the target, you can see here what is the target, you can see here, or if you want to know what is the data, you can see here. I can print so we can see here, yeah, 5.1, 3.5, 1.5, 0.5. This means you can see here there is four attributes. One is the sepal length, sepal width, petal length, petal width, and total. I want to know that size is. I want to know the size. So you can see here, shape is shape of iris dot date iris data. You can check. You can check the shape will be 150 comma 4. That means 150 rows is here and 4 column is here. Got it? So I want to take this iris data. I want to take here iris data, iris then data as an input. So you have to see here this X is convention. Like you should follow the convention. Like in a standard input, symbol is X. So you have to also follow X for input, and this should be capital X for input. It is not mandatory. You can put any characters. Okay, but here if you are following a standard, so you can look. That means if you are following a standard, so you can easily find out. Anyone can say, hey, this is the X. That means input. Even though if you go with the official documents, they are also they are also they are using X for input, right? Then I want to take a Y. What is the Y? Iris. So tell me, what is the I can take here? I can take here target. That means I have already described for machine learning. Let me plug charger, please. Sorry. Okay, so we can take here Y is equals to iris target. So as of now, we have completed two steps. What is import all required modules? Then step 2 will be you have to load and understand the data. So tell me guys, what is the next step? Step 3 is split data for training and testing. You have to split data for training and testing. Split data for training and testing. So this is step 3. Step 3. So as we know that for splitting, I have one function called train and test split. If you know here, you can see here it takes like a X and Y. For splitting X and Y, X as an input and Y as a output. Okay, and then it will gives that you can take here train underscore size. So you can see here what is the, let me describe first test underscore size. So what is is the test underscore size is, by default this test underscore size is set to the 0.25. so what is the meaning of 0.25 means, like 25% whatever data you are passing here. Let's suppose you pass 100 sample. Okay, so from 100, 25 25 data will be become as a test data, so this is called test underscore size. Then remaining will be automatically become as a training data. So what is the training data? 75% will be become training data. Then in previous session I have already described what is stratify. So stratify means nothing but you have to maintain the ratio, whatever ratio which is in your sample data, that same ratio you have to pass for training and test. So let's suppose yeah, okay, so whatever stratify, I think I have already described stratify in depth. Stratify. So coming to that, coming to here, train underscore test and split, then you have to pass x, which is input, then you have to pass y, right? So what you have to pass x, then you have to pass y, then you have to pass, let's suppose you what things you have to pass x, then y, then next one is you have to pass here, test underscore, let me write here, test underscore size. You have to pass here test underscore size. I don't want to take a default size, I want to put here 0.3. so what is the meaning of 0.3 means? 0.3 means 30% of data will be trained data. Got it? 30% data will be the trained data. So train, so what will be the train? 30% of 150, what no, test underscore size is 0.3, that means 30% will be test data and remaining will be train data. So remaining 70%. So what is the values of 150? 70% of 150, 70% of 150, yeah, 105, and remaining will be what is the test? 30%. So 30% means 45. Got it? 30% means 45. Then after I want to describe here random underscore state. Random state is nothing but seed, reproduce. What is the meaning of random underscore state? Means nothing but seed or reproduce. I have already described what is the seed. Seed means like if you are passing that random underscore state, so randomly, on every system the data will be randomly picked, same data. That's why I'm applying here random underscore state is equals to 21. Okay, so whatever result you will be getting, same result I will be getting also. Okay, then after I need to pass here, then after I want to pass here what is stratify. I want to pass here stratify is equals to y. So what is the values? Y stratify is equals to y means, let me close here. Stratify is equals to y means, what is the meaning of stratify is equals to y means, like a input data ratio, input data I want to pass here, that means input data ratio. What is the input data ratio? it should be, it has 50 50 50. That means 50 data is from Sitosa, 50 data is from 50 data is from 50 data is from Sitosa, 50 data is from Vergicolor, 50 data from Virginica. So same as it is according to train and test ratio should be, that means same as it is according to train data ratio, what data ratio should be also same. That means let's suppose train data ratio is 35 is to 35 is to, let's suppose you write here 40, so it is not suitable. That means it will be take same ratio. So this is the meaning of stratify. In previous session I have already described. Then after remaining will be test data ratio. So what is the meaning of test data ratio? Test data ratio means, test data ratio you can say next will be 15 ratio 15 ratio 15 ratio 15. Got it? So let's execute here. Then after I want to, so we can see here from here as an output, the output of train underscore test underscore split will be, it will give four different four outputs. Like one output here we can find out x underscore train x, and I am writing here from input data we can get from whatever input data you are passing, from after the applying of this function you will be getting the, in return you will be getting for input data you will be get train data set and then test data set. So I want to represent that train data set is for I want to represent that train data set to x underscore train and x underscore test. Then for output also it will return train and test. So what is the meaning of train test split? That means once you execute this train underscore test underscore split, it will return four values. One values will be for, so you can see here, this is our train data, this is our input data. So for input data it will gives it will for input also, that means this is our x. For x also it will split this x into the two parts. What is the two part? One is for training data, one is for testing data, test data. For output also, like what is the output? You can see here y is the output. So for y also it will split the data into the two parts, train and test. So I want to hold this four data into the four variable. One variable is called x underscore train, another variable is called x underscore test, then another variable is called y underscore train, okay, and then another variable is called y underscore test. So after the execution of this line, we got the data splitted. That data is splitted, our x data, that means input data also is splitted into the x underscore train and x underscore test, that means training and testing. Output also, label also splitted into the y underscore train and y underscore test. Got it? Got it or not? Then after, so I think you have already, so did you understand what is the stratify, what is the random state? Yeah. Coming to that step 4, what is the step 4? Coming to that step 4. What is the step 4? For step 4, we have to fit the model. Step 4, we have to fit the model. So how can you fit the model? How can you fit the model? As we know that first of all, we have a KNN classifier. In this KNN classifier, I want to take neighbors is equals to 8. By default, neighbors will be 5, but I want to take n underscore the values of n underscore neighbors is equals to, I want to take here 8. Okay, and then I want to pass this kn 8 to the one variable is called kn. Then after I want to fit this model, I want to fit this model. For fitting, we have a one variable value function is called fit. You can see here what is the fit. In fit, it takes x comma y. What is the x? X is input. What is the y? Y is the label. That means it will fit the model using x as a training data, and y as a target values. So here what we have to passing here, we have to pass here for fitting, you have to give training data. What data you have to provide? Tell me guys. For fitting means you have to give what data? Training data. That means you say like I'm fitting you. I want to give the guidelines. I want to train you. I want to fit you. So you have to see here x as a training. What is the x here as a training? And what is the y as a target values? Right, you are right. So here what we can pass here, kn dot fit, instead of that, what you have to pass here? Train data. So what is the training? What is you have to pass training data. So what is the training data we have? Train data from our data set. We have exploited input data. So these are the input data. Yeah, x underscore train and y underscore train. So simply you have to pass here for fitting the model. You have to pass here x underscore train, comma y underscore train. Got it? Kn dot fit x underscore train and y underscore train. So once I'm training the data, you can see here by default algorithms you will taking auto. That means B-tree, ball tree, KD tree, anyone. Leaf size 30, Minkowski taken 8 and n neighbors is 8. Instead of 5, it is taking 8 because explicitly we provide here 8. Weight is uniform. So coming to that next one. So we have trained the data, that means feed the model. Then I want to know the prediction of machine. I want to test the data. So predict labels of test. Which one? Test data. So this is a step 5. This is in step 5. So for predict, we have a one function is called knn dot. We have a one function is called predict. You can check here what is the predict. So you can see here in predict, it is taking only one input argument x. What is the x? X arrays like shape, and this is the test sample. So predict the class level of the provided data. So you have to pass test data as an input here. You have to pass test data as an input here. So what is our test data? what is our from our training data. That means let's suppose I have 100 data. From 100 I pick some for training, and rest I let's suppose, hey, you can see here, we can see here, let's suppose I have a 100 data. So for 100 data I taking this data for training, and I want to test this data only. Got it? So here, we can pass here, a Canon dot predict, we can pass here x underscore what test, x underscore test, x underscore test. Here we can pass here x underscore test. So once I'm passing here x underscore test for this input, I want to test x underscore test data, and from here I want to find output. Whatever test data I'm giving, after the prediction I want to get some prediction values. So let's suppose the variable I defined here y underscore predict, let me execute here y underscore predict. Hey Venkat, you can see that we have to pass only one parameters here. You can see that predictor, you can see here, you have to pass only one parameter, x. This is x as a test that you have to pass here. You can see what is the predict function. This is the function, it is taking x, predict the class level for the provided data. So whatever data, you can see, yeah, got it. You can see how the code is here. Okay, yeah, fine. So next one is let's suppose I want to print this data into the format. Print, I want to pass here, I want to write here print. What is print? Test set prediction, test set prediction. Okay, then I can pass here. Let's suppose I want to write this into the next line and next, so we can pass here /n. Okay, /n. Then as I have already described what is the meaning of this one. Whatever the objects you will be getting, this object will be assigned to this curly braces. Okay, and that we have one form is called format, and this format we can pass here y underscore predict. So this one what is y underscore predict? Yeah. So let me execute here. So you can see here test set prediction is 212211001100. This. So this is the way for test one prediction. I want to observe here what is our y underscore test. You can see here y, this is our test. This is our test output. This is our test y underscore test here. This is our test data for output. Got it? This is our test data. But what is the prediction data? What is machine giving? Machine is giving this data, and we have giving this one y underscore 22. Now we will compare. You can see here, yeah, 2 is fine, 1 is wrong. Here one data is mismatched. Yeah, 2 is fine, 1 is wrong, because here we provide an actual data 2, but machine is predicting 1. Yeah, so this is fine, this is also fine, this is also fine, this is also fine, this is also fine. So you can match with this is our predicted data. This result is given through the machine. This is our actual data. This is the right results, but the machine is giving this one. So how to calculate accuracy? Let's suppose I have given you 50 questions, and out of 50 questions your answer is 48 answer is correct. So what is the percentage of your accuracy? How to calculate the accuracy manually? Tell me anyone, please. Hey, the session is going boring, man. If the session is going boring, tell me. Man, I'm asking, I'm not asking the coding, I'm asking how to calculate manually. Yeah, you are right, Bharat. Okay, so we can see here y underscore test, and I want to know here np dot bin. We have a one function is here bin count. This is for count. You can see here I want to pass here y underscore print. Bin count means like a different counts. Y underscore predict. So you can see here we have a total data is, you can count here, total data is almost 45, I think. This is 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. So this is a 22 22 44 and one is 45. So you can see here bin count means it will find the district count. Okay, so we have a 15 0, we have a 15 1, okay, and we have a 15 2. As we have taken here, we have taken here stratify is equals to y. Stratify is equals to y. Right. So what is the y? What is the y here? You can see here y is equals to 45. Y is equals to 45 here. Right. So from our bunch of our data set, we have taken here from 50, I have taken here 15 only, 15 result. 15 from Setosa, 15 from Versicolor, 50 from Virginica. So this is our test data and this is our predicted data. Got it? Now I want to know accuracy. Now I want to know accuracy. Now I want to know accuracy. What is the accuracy? Accuracy underscore score. If you want to know what is accuracy underscore score, you can say here you have to pass y underscore true, y underscore pred, normalized true, sample with none, accuracy classification score. So here you have to pass two things. One is y underscore test. Okay, so you have to pass your tested data, actual data, y underscore test. On the basis of that, you have to pass your predict data, y underscore predict. Right. Then you can say, you can find here what is the accuracy. So first you can calculate that actual accuracy here. Kindly map with that this data set and then data set, then you have to verify the accuracy result is saying, wow, so we are getting here 95% accurate. That means our model is given 95% accurate results. What we are, maybe you have no man, it should be why 97%. Any mistake you have given? Why you are maintaining a 35? Why man? Are you using same data? No man, you have. So that is the only yeah. Here, no man, your bean count is why bean count is different. Bean count should be 15, 15, 15. Don't take 15, 14, 16. Don't take 15, 14, 16. Because in our actual, what is the meaning of S35? I have already described. In our actual data set, the ratio is same. The ratio is 50:50. So whatever data you have to take in from sample, you have to maintain that S35. You have to take, let's suppose you are taking 5 data. So you have to take 5 data from here, 5 data from here, 5 data from here. That means their actual ratio should be maintained. If you are taking here 10, so you should take here 10, then 10, then 10. Because here the ratio is 1:1:1. Same ratio you have to maintain 1:1:1. 110 is 1:1:1. Got it? So today we have seen here how to find. We have seen here how to find accuracy apply it using KNN algorithms. In next session, okay. So rest we'll see in next session. As of now, we are good with. Okay. So in next session, I will start with first. I will revise the previous one. Okay. Algorithms, and then we'll back on hyperparameter tuning with grid search CVV. Okay, what is the benefit of grid search CVV? Okay, and then we'll come back with the what is the step 3. The step 3 is nothing but man, it is taking. I'm trying to split the data into the training and testing data. So we have a x means input. So I have to 150 50 you can observe. Hey man, I have already described in our data first session only. You can go with the yeah, data sets. Yes, you are right. In data sets I have described here, man. I think you have missed. In data sets, I have described here each one. You can go with that result here, and you can observe here that 50 data is belongings to that Sitosha. 50 is belongings to that Versicolor, and 50 will belongs to that Virginica. You can observe that. You can see here. total is 150. You can see instance hey man, why this is input data. That's why I'm passing here STATify. What is the meaning of STATify is equals to y? Tell me. What is the meaning of STATify is equals to y means from this is our actual data. Machine does not know their actual data because right now in coding we are not providing this one 50-50. But we are providing this test STATify. So that's why I'm passing here y. So total y is y. What is 50? From 45, machine will be automatically through that STATify is equals to y. It will be divided into the three parts. That means according to that actual data set. Kindly observe your data. You can, yeah, you are getting here STATify is equals to y. That means we are passing here this one. Don't forget about this one. But this code is we are passing here. What is the meaning of STATify is equals to y is what is the actual values of y? Y is we have total y. You can see here we splitting here into that 45. So same ratio automatically it will be maintained here 15 into 15 into 15. Got it? Okay. Thank you.